In this problem, I'm asking you to find the dimension of a rectangle with perimeter 100 meters whose area is as large as possible. Okay, so if we're going through our steps, we have a rectangle. So we have that, and then it says area is as large as possible. That means we want to find max area. I know the formula for the area of a rectangle is area equals length times width. Okay, so that's my equation that I need to be optimized. So I have to write that length and width equation in terms of one variable. Now going back to my rectangle for just a second, I'm going to call this side the width, and I'm going to call this side the length. And you can call it, you could have labeled them differently, it doesn't matter which side's the length and which side's the width. But what I know about this is the perimeter is 100 meters. So remember, perimeter means add up all the sides. So if I start at the top and go right, and then go to the bottom, and then go to the left side, that's going to give me 100 meters. You could also use 2L plus 2W. That would actually be the next line. Okay, so that's my other fact, where it says write this equation as a function using other facts. Now the next question is, which letter do we want to change it to? It doesn't matter. If you want to put everything in terms of W, great. If you want to put everything in terms of L, great. It doesn't matter. I'm going to choose to solve for L. Either way would have worked. So 2L would equal 100 minus 2W. I'll divide both sides by 2. So that means L equals 50 minus W. Okay, so let's go back over here to my area function. Area equals length, which is 50 minus W, times width. So area equals 50W minus W squared. So now I have the function written using one variable. Step 5 says optimize this function over its domain. Okay, to optimize this function, I need to take the derivative. Okay, first of all, let's make sure it's written properly. So the area function is 50W minus W squared. 50W minus W squared. Okay, we got it. So now I need to take the derivative. So the derivative is 50 minus 2W. I need to set that to 0. 0 equals 50 minus 2W. Okay, I'm going to move the W over. So 2W would become positive, equals 50. So W would equal 25. Okay, so 25 is my critical number. Now let's look over here and find our domain. First of all, when we're talking about width, the width has to be positive. Okay? I also know the length has to be positive. So that means that 50 minus W has to be positive. Okay, if I move the 50 over, negative W has to be greater than or equal to negative 50. Divide both sides by negative 1. Let's try that again. Negative W would be greater than or equal to negative 50. I'll divide both sides by negative 1, and when I divide by a negative, my sign flips. So W has to be less than or equal to 50. So now then, you see two different constraints written on W. You see that W has to be more than 0, but it has to be less than 50. So when we're talking about optimizing over a domain, that domain would be from 0 to 50. Now, when we get ready to work this one, there's my area function. I have 3 values for W, 0, 25, and 50. So we're going to plug those into our area function. So if I plug in 0, I get 50 times 0 minus 0 squared. That would give me 0. If I plug in 25, I get 50 times 25 minus 25 squared. Okay? So I'll figure that out in a second. And if I plug in 50, I get 50 times 50 minus 50 squared, which would equal 0. Let me grab a calculator quickly. Okay, so when I plugged in my 25, I got 50 times 25, which was 1250, minus 625, which would give me 625. So my maximum area, I had three choices, 0, 0, or 625. So my maximum area was 625. The question, though, said find the dimensions of the rectangle. Well, that would be length times width. The value for the width that gave me maximum area was 25. So the width is going to be 25. Now, we have to find what the length will be. We'll look over here. You see that the length equals 50 minus W. Well, W is 25. So, since the length is 50 minus 25, it would be 25 as well. So your length would be 25 also. So 25 by 25 would be your answer.